In just 10 minutes, let's learn how to leverage Particle's smart wallet as a service on ZetaChain. At Particle, above all else, our goal is to simplify user experience and solve fundamental points of friction in Web3, which is exactly why we are so excited to support ZetaChain within our smart wallet as a service, as they're addressing one of the most potent issues in Web3 head-on. This is interoperability. ZetaChain essentially connects all L1s and L2s, including chains like Bitcoin, directly in one place, basically abstracting away the multi-chain experience from users and even reducing complexity for developers. This is directly aligned with our mission in the ecosystem to create next-generation Web3 applications. Thus, our newest integration within our smart wallet as a service is native support for the ZetaChain testnet. When you're building an application on ZetaChain, you can now leverage Particle's smart wallet as a service to initiate social login, onboard into a smart account, and immediately start using Web3. You can even do things like sponsor transactions, do batch transactions, use session keys, and so on. Essentially, we're bringing our stack of UX solutions natively to ZetaChain to enable developers to build very powerful user-centric applications. So this is why today, in just 10 minutes, we're going to be creating a demo application that leverages our smart wallet as a service to initiate social login, deploy a smart account, and send a gasless transaction on ZetaChain. So let's jump right into it. So as I mentioned, we just announced full support for the ZetaChain testnet on our smart wallet as a service. So today I want to clarify and show an example of how you could implement smart wallet as a service within your own application on ZetaChain. To do this, we're going to create an application that'll be around 90 lines of code. And within this application, we'll handle account management through social login. That includes an instance of SimpleAccount, a smart account implementation that we're using for ZetaChain. We'll also do things like balance retrieval and of course the actual execution of a sample user operation. So let's start by importing a few different base libraries. We can start with React and specifically use state and use effect. We can also import particle network from @particle-network/auth. Additionally, we can do particle provider. That'll be from @particle-network/provider. And this is optional, but we'll be configuring our application to use ZetaChain through this import of ZetaChain testnet from @particle-network/chains. We can also import all of our account abstraction objects, such as AA wrap provider, smart account, and send transaction mode. And this will be from @particle-network/AA. And to close it off here, we can import ethers and notification from &d. Then finally, we can go ahead and import our CSS. All right, so now with all of those base libraries imported, let's move on to setting some initial configurations before we create our main app component. Let's start with a variable called config. We'll be using this 2 different times, and essentially it contains 3 universal required values that you'll see pop up repeatedly when you work with Particle. This is your project ID, your client key, and your app ID. These values essentially connect your application with the Particle dashboard, enabling customization, analytics, tracking, and so on. So let's fill in these values by first heading over to the Particle dashboard and creating a new project. Okay, so now I'm here on the Particle dashboard. I'll head over here and click add new project. I'll name this something simple like ZetaChain demo and click save. As you can see, there's a ton of different options, including our paymaster, bundler, customization, etc. But in this case, we want to focus just on this applications menu right here, because in our case, we're going to need to create an application that corresponds with our project. Today, we're building a web app, so I'll select web. I'll name this ZetaChain demo, and I'll include the domain in which I'm hosting that application right here. Although you don't need to include this. If you're running this locally, then you can do any placeholder here, it'll still work. So I'll go ahead and click OK. And now with that done, I'll copy the project ID, the client key, and the app ID. Then I'll throw these into environment variables and we can move on to defining the config object. Let's start with project ID. In my case, this will just simply be process.env.react app project ID. We can do the same thing for client key and also for app ID. Okay, so now with that config object set, let's actually use it in 2 different declarations. The first will be the particle variable. This will act as our sort of master object for configuring and interacting with Particle in a moment. So let's call this particle and set it equal to new particle network. And to start, we can actually just pass in the config object. This will copy the values from config over to the particle definition. And we can also set chain name as the primary chain that we intend on using. That'll be, of course, ZetaChain testnet.name. We can do the same thing for the chain ID. And we could also set a very simple configuration here within wallet. We go ahead and set display wallet entry as true. This will essentially create a little pop-up on the application that allows the user to enter the wallet if they'd like to. Okay, so now with that defined, we can also create a variable called smart account. This will basically handle the core account abstraction functionality, and thus we can set it equal to new smart account and pass in new particle provider, which is just our standard 1193 provider, and that takes particle.auth. Within smart account, we can pass in config, just as we did within particle, and we'll also need to configure this parameter here, AA options. Within AA options, we can tell Particle Smart Wallet as a service what type of account we want to use in this case. And of course, because at the moment we only support SimpleAccount for ZetaChain, we'll need to basically tell this that we want to use a SimpleAccount implementation on ZetaChain. So let's do this within account contracts and define simple, then set the chain IDs to just ZetaChain testnet.id, and we can set the version to 1.0.0. Another small thing to do while we're here is go ahead and do particle.set ERC437 and set name as simple and the version as again 1.0.0. This will essentially tell the wallet UI that we want it to display the smart account, specifically the simple account, tied to the EOA generated by particle auth. Okay, so before we move on to creating our main app component, let's go ahead and define potentially the most important variable here, which is custom provider. This is going to be an ethers object, providers.web3 provider, that takes in our 1193 account abstraction provider to route transactions as user operations within ethers. So we can do new AA wrap provider, that'll take smart account, as well as send transaction mode .gasless. By setting the send transaction mode to gasless, we're basically going to have all of our user operations or transactions automatically sponsored. Our paymasters in the backend will automatically sponsor transactions that use this mode if they are on a testnet. Otherwise, you can use our paymaster, as you might have noticed in the dashboard that we just looked at a moment ago, to deposit USDT and sponsor transactions yourself. And then finally, we can close this off just by passing in any. Okay, so let's move on to creating the main app component. We can define this as app. Basically, this will contain all of our main functions as well as our JSX for the application itself. Let's start by defining two different states. The first will be user info. That's associated with set user info. We can also define balance, set balance as use state. Okay, so now with the set, let's start by creating our logic for continually retrieving the balance. The only reason we're doing this is to display the balance on the front end, but we can achieve this sort of updating balance mechanism in about 7 lines of code. So we'll be doing this within a use effect. And within this use effect, we're going to update the balance on the condition that user info is defined. So we can do that as if user info returns a truthy or falsy value, then we can move on to the balance fetching logic. And here we can create a function called fetch balance, and this will just be 3 lines. Basically, we can start by defining an address. That'll be await smartaccount.get address. That'll of course return the address of the smart account that we've tied to our EOA. Then below that, we can retrieve the balance with await custom provider.get balance and then pass in address. Then we can go ahead and set balance as ethers.utils.format ether and then pass in balance. Then of course we can go ahead and call the function right here and close out the use effect by making it dependent on user info. We also need to create a function for handling social login. Let's name this handle login, and this will take one parameter called preferred auth type. Basically, we can do this just within 2 lines, specifically by using a 1-line conditional, which we can save in user. And in here, basically what we need to do if the user is logged in or not. If they are logged in, then we can just pull and return their user info. Otherwise, if they're not logged in, then we need to log them in with particle.auth.login. So let's first check if particle.auth.isLogin is true or false. If a user is not logged in, then we can simply call await particle.auth.login and pass in preferred auth type. Otherwise, if they are logged in, then we can do particle.auth.get user info. Then we can just do set user info and then pass in user. So regardless of if a user is logged in or not, we're populating user with the user's information because particle.auth.login returns user info upon a successful login. And of course, if a user is already logged in, then we can just pull it with that second method call. Okay, so we're almost done. We just have one more function to write, and this will be execute user op. Essentially, we'll be creating a function to just very simply send a sample user operation, which in this case will be the burn of 0.01 zeta. So we can call this execute user op. And within this function, we can start by defining a signer, which we can just do with custom provider.get signer. Then below this, in one method call, we're going to send our transaction. Let's save that in a variable called tx response and do await signer.send transaction. Then in here, we can directly pass in our transaction details. In our case, this is just 2 fields. 2 and value. For 2, we're going to mark this recipient address, which is just the dead burn address. Then for value, we can set that as ethers.utils.parse ether and pass in 0.01. And that's it. We can then just simply throw a notification.success and say transaction successful and set the description to json.stringify and pass in tx response, which will basically just throw the transaction response on screen for us to see. And that's it. We configured all of our main variables here, retrieved the user's balance, handled social login, and executed a sample user operation, all in about 65 lines of code. Let's move on now to formatting all of this and mapping it to the front end in our JSX. I usually tend to skip this because it can be a little bit time consuming. So let me get this done and then come back. And there we go. Basically, all I'm doing here is checking if user info is defined, meaning if a user is logged in or not. If it isn't defined and they aren't logged in, then we can throw the sign in with Google and sign in with Twitter buttons here. Of course, we have more social login mechanisms, but I didn't want to overcomplicate it. So in this case, I'm just using Google and Twitter. Then once they do log in with either of those mechanisms, then we're displaying their name, their balance in Zeta, and of course, mapping the execute user op function to this button here, as well as creating a disconnect button. Basically, all this does is call a simple 1-line function that does particle.auth.logout, which will sign a user out of the application. Okay, so all we have left to do now is simply do export default and then app, and now we're done. So let's go ahead and give it a try and see if it works. And as you can see, it looks like it worked. We have the particle logo and the ZetaChain logo, as well as our two buttons, sign in with Google and sign in with Twitter. Let's go ahead and try to sign in with Google. As you can see, I have my accounts here. Go ahead and select this one. And there we go. I'm logged into my account proxy. I have 2.778 Zeta, and I have the wallet pop up right here that we defined a moment ago. I want to go ahead and give the execute user operation button a try and see if that works. So we can go ahead and click it, and there we go. We have the confirmation pop up. So let's click on confirm, and there's the transaction right there. And if we go ahead and refresh the page, then you can see my balance is also changed to reflect the fact that we just sent 0.01 Zeta. We're really excited about the possibilities that ZetaChain will create for the ecosystem when it comes to interoperability. We hope to be a direct part of that, supporting on the user experience and onboarding side with our wallet as a service. If you'd like to learn more about our wallet as a service, then I'll have the video explaining that linked below. Additionally, you'll find this demo, our main web demo, and the repository for the application built today all linked below.